Hello. So today we are going into session 5, and that will be processes, services, and system D. Thank you for joining me on this learning journey. So the story so far, a new alert has come into our team channel and is addressed to us. Remember, you are acting as the intern on this project. One of our test servers is running slow and we don't know why. Before we can fix anything in production, every engineer needs to know how to look at a running system and answer what is running, how much resources is it using, and how do I stop or restart something safely. Today's ticket: investigate a slow server, identify the problem process, and write up what you found. So that's the tickets that we have for today, and that's what we'll be walking through. So these are the things you're going to learn. I'll of course drop the GitHub link in the comment section so you can clone and replicate the same in your own system. So a process, what is a process? A process is every time you run a command on your terminal on Linux, a web, something like ls, nano, vim, a Python script, a shell bash script, it creates a process to run it. So a process normally has a process ID, which is very unique, a parent ID, which you see as PPID, its own memory space, and a status, which is maybe running, sleeping, stopped, or zombie. Then we have foreground processes. These are processes that when you run, it kind of holds your um, terminal. So you won't be able to type any other instruction terminal. And the background process is the one that runs behind the scene. It doesn't block your terminal because you add this ampersand sign to the end of the command. And the service is a process designed to run continuously in the background. So most of the time, a service spins up processes for a process. So process is a subset of service. And then we have the system D that manages the services, which helps the service to start at boot, restart the service if they crash, and also has the command line to systemctl to control the service. So for today's lab, this is where we're starting from. So you can see the into your project folder, and then let's view the running processes on this system. To do that, you run the command ps. Okay, so it's telling us this is the PID, process ID 1271, and that's the process right here. And now the PS that we just ran here, this PS, you see, it actually spun off the process. So this is the process for this command that we just ran, the PS command, and that's the process ID of the command. So to see every command that's running in full detail, you run PS AUX. It actually spits off a lot of commands, a lot of processes that's running in the background. And their process ID, this is their CPU usage, this is their memory usage. So yeah, so right now we have this process. That's the one that's using the most CPU and memory because it's sorted according to highest CPU and memory usage. Okay, so in the script as well, there's a breakdown of the user, which you see here, the PID, the CPU percentage, the memory percentage, the start status, which is here, and the command that is running. Okay, so we can also run. Let me quickly get my screen. So to see processes in a live view, you can do top. So top gives you a live view of the processes that are running. So this is a live view. If you look at it, you see that it's changing. It's not static because it's a live view. So you see it's refreshing. So this just changed. The value just changed. See that it's changing. So that's a live view. And then to come out from here, you press the Q. Press Q, and you come out from the top screen. Then there's the stock, which gives you like a colored interface that's more interactive. Okay, so you can use arrow, you can see the sign F1 help, F2 setup, and F9 kill, F10 quit. So you can see this changing. It's also a live view. The same thing with talk, just that this is more interactive. Okay, so we press the Q button to also come up from each talk. Now we'll move on to part 2. Let's try and find a specific process. So to do that, we still run the PS command AUS, but then we are going to use the grep command. And remember in our previous session, grep searches for a pattern that you give to it. So it's going to search for all the processes that has this assigned to it. So if we enter that, we see that this is actually the process that's running, the bash. Right? This one right here came up because of this command that we run. So any process that's running. So this command we also give it is also running a process, which is this second one right here, right? Because if you look here, you see that the command is actually grep, which is this, while this is actually the bash process that's running. Okay, so if we run p grep bash, you see it's giving us the PID of the bash process itself, right? Yeah. So that's actually the process that's running. This other one is just the command that you run up here that has bash in it. Now let's get the PID of our current shell. To get that, we do echo the double $sign, and there it is. The same bash that we're using, right? The same bash terminal. That's the same PID. Now let's move on to part 3, where we talk about foreground and background processes. So when you run a command that takes time in the foreground. So let's run this command, sleep. So sleep is a command that will run in the foreground. That's it's gonna, if you see, it's hanging. I can't type, I can't really do anything else. I need to wait for it to finish running before, like my terminal is frozen for 30 seconds before it gives me back my terminal. So let's just hold on. We could also do Control C to cancel out of it. But and then we could also send it to the background. So you see, it's giving me back my terminal. Now let's run this and practice how to send it back in the background. So to run a process in the background, we append the ampersand sign. And there we go. It gave me back my terminal immediately. Didn't freeze it. But if you do job, you see it's running in the background right there. So it's still running in the background, right? It does its jobs. Then if you want to send it to the foreground, bring it up. You do FG foreground percentage sign and 1. If you click enter, you see my terminal now is frozen. Yeah, I have to wait for it to finish running, or I send it back to the background because this command brought it to the foreground, which is the front. So it's either I wait for it to finish, or I could also do Control C to stop it. But let's wait for it to finish, or rather, let's send it to the background again. Okay, it's done. So it's giving me back my. So if we run jobs right now, it's done. Or let's run it again. E60, and send it to the background. Oh, sorry. Ampersand file. So it's running now. Now, let's send it to the foreground. So if you remember the command, that is fg %1, and it comes to the foreground. And then let's send it to the background again. So we do Control Z, and then we bring it to the take it to the background, which is VG. So you see, it goes to the background now. So Control Z stopped it, and then BG brought it, took it to the background. If you do jobs, it's still running, right? It's not done, it's still running. So yeah, so we've explored how to start the process, how to send it to the foreground, bring it to the background, and send it back to the foreground. Okay, so let's continue to part 4. Meanwhile, this is still running. When it's done, it's also gonna show. So now it's done. And then if I type jobs again, it's no longer showing. So it's done. Now part 4, stop a process with kill. How to stop a process with kill with the kill command. Yeah, yeah. So we run the command split 300. So these numbers is like this 60 is in seconds. So these numbers are in seconds. So 300 seconds is 5 minutes. So with this, we already know that we are sending this job to the background. It's continue running in the background. We do jobs, you see it's still running, right? So we've noted the PID. Now to find it, although it's already shown here, but you can find it, you can find the process, running process with pgrep, the name of the command, or you can also use the PID to find it. So if you are looking, let's say you want to kill the process and you don't know the PID. To find the PID, you use pgrep and the name of the process that's running. Okay, so pgrep will give you the PID right here. Now let's stop it. So you do kill 1593, enter. The process is there. So if we do jobs now, you see it's no longer running because it's supposed to run for 5 minutes. Okay, so now, so that's it's all on the script. I'm just going probably a little bit ahead of the script for CS. Every step you need to follow is on the script and is also explained. So if a process refuses to stop with a normal kill, the normal kill command, you force it with stick kill. Because there are some processes that when they are running, maybe something else is using the process. Um, Maybe a service is, like I said earlier, when you run a service like Nginx, Docker, those bring up multiple processes. Might not just be one process. So that's why process is like a subset of a service. So um, in some cases, when you try to kill the process, because a service is still using it, it might not terminate like in this scenario here. So in those cases, you might have to force it to be able to proceed. So let's do that. 200, to kill. So the -9 is the first, and 1641 as the PID, and it says killed. So that's different. Terminated is graceful killing, though it stops the process gracefully, but this forces it to stop. Dash -9 is forceful. Okay, so let's run job. You see the process is gone. Now let's move on to part 5, where we'll be installing We are installing an engine service, a real service. So to do that, we run sudo apt update. Okay. So normally you should also run sudo apt upgrade, but let's proceed because we don't want the video to be too long. So run sudo apt install the try service. Okay, fully installed. Now let's get the status of the service that we just installed. To do that, you use the command systemctl status engine. So if you see here, you see that it's active. The service is active. Engine service, a high performance web server, and a reverse process server is active. It also gives us the PID of the service right here, the memory and the CPU. Okay. So, and it gave us a little bit more information about the log of this service. Okay. So now let's stop the engine service. To stop it, we do sudo systemctl stop engine. And now, if you run the command of the status again, you see that it's inactive dead right here, right? It's inactive, is dead, even though it's enabled, right? It's enabled, but right now, because we stopped it, it's inactive. And if we look at the log, we see changes. So initially, it starting, we see started, stopping, deactivated successfully, and then stop. Okay, all this is logged. Then let's start it again. Sudo system detail start engine. And then if we do sudo system detail status engine, it's back active and running. Okay. So you can also do system restart. So this way you stop and start. Just the same way you can restart your laptop or your phone. That same way you can restart this service. So in one with one command, that means stop and start again in one command. That's when you use it. Then we also have systemctl reload engine. So this is usually used in production where you don't want the system to actually stop. You don't want to disrupt the service that's running. Maybe you made configuration changes, you added a different address, or you did a configuration change on the engine's configuration file. In that way, you wouldn't want to completely stop the service because it might throw off some of the users of your product or your service. So you just reload and it's less disruptive as captured on the script. Okay, so let's move on to part 7. Clear my screen. So in part 7, we enable a service to start on boot. So when you enable a service, it means that if the system is rebooted, maybe you change your instance type or you change the virtual machine where the service is running, it automatically starts. If it's not enabled, it wouldn't start. Okay, automatically. You will have to come back and do sudo systemctl start or restart, like we just showed up there. So let's find out if our engine service is enabled. So we're asking systemctl is engine is enabled, and we see that yes, it's enabled. So if it wasn't, if you had said disabled, we would have run this command to enable it. So let's actually disable it with this command here. You notice I'm typing out all the commands. I'm trying to type because it helps to build muscle memory and helps you to remember the commands. Okay, so we've disabled the service. Now let's ask that same question again and see what it gives us. You see, it is disabled. So now let's enable it. So to enable engines, we do run this command. Okay, so now if we run the command again, asking if it's enabled, we see that yes. Okay, so if you're using WSL, you might get an error message. Um, Note that in your reporting, and there's a way around it, but hopefully this should go through. But when you start running it on AWS instance, you wouldn't have that issue because right now, if you notice, I'm actually running this command using an AWS Ubuntu instance. Okay, let's move on to part 8, where we verify that Nginx is actually working. Remember, Nginx is a web server, right? So let's check what port Nginx is listening on using this command. So this command basically is asking for the socket statistics, that's SS, and then we want to check if the type of port is it TCP, is it TCP traffic or UDP traffic? Is it listening on which port? What's the port number? And what is the process using that port number? That's the TULNP. So the socket statistics, the TCP, is it the UDP? So we're trying to find out what port Nginx is listening on. It shows us the breakdown is also here. It shows network socket information, TCP, UDP, listening ports, port, port number, and the process. So if we run that, I will have to grep for Nginx. If not, it will give us the order of ports. So we see right here the TCP is using TCP, not using UDP, right? It's giving us the process number right here. All right, and it's telling us the port number. This is it right here, 80. This is the IPv4 network addressing, and this is IPv6 network address. So if you notice, the both it gave us two, but it's the same. This is IPv6 and this is IPv4 network address type. Okay, so now let's test it directly using curl, the curl command. So to do that, we this call command http localhost, and we enter. So there you go. You see the page displayed, the HTML output right there. Welcome to Nginx. So let's proceed with part 9, where we actually read service logs with journalctl. If you remember when I started and stopped the Nginx service, something was actually entries were actually seen in the log, Nginx log. So we can easily use this command to view the logs. Journal dash u. So u is like we are telling the journalctl command to give us logs for this particular service. You know, for this particular service, Nginx, right? So this is the log that we currently have, which was when we stopped the service and then we started it back up. Now, if we had more logs, we would have been able to view maybe the recent 20 lines, but we could also go ahead and actually view maybe the first 5 lines. Show index -n, which is the number of the lines, and we do 5. So you see, it's given us only 5 lines of the log. So we can also use another command that actually follows the log. Maybe you're trying to trace or troubleshoot a service and you want to actually see what's going on. So you can follow the logs, which means it's going to give you a live logging. You actually see what's happening. So to do that, we need to open another terminal by the side. So now I have to, so I need to log into. So let me run the command here. That will follow my log. So now this is showing our login live. So let's run engineers system system. Let's try and stop the service and start it back up. Sudo systemctl stop engineers, or let's do restart instead. So restart engineers. While you watch on this side, what's going to happen, right? So you see, we added some logs. So what happened? It stopping. This is where the log was initially. Let me move this over to this side. So this was where we were, and then and now we stopping, deactivated successfully, stopped, started, right? So let's also do system. Remember, we're learning here, right? Reload. Let's see what happens with reload command. Reload engine. So you see what happens. This is where we were. Then we added extra logs. Reloading. Signal process started. Reloaded. So it didn't really stop. So you see why it is safe to use this command instead of restart or stop and start in the production environment. That way your system doesn't really stop completely. So you can also use this command to check what happened in this particular service for a particular service in a duration of time, like 1 hour in this scenario. Okay, so let's move on to part 10. Clear my screen and then move this to the side. So let's see what's actually, we run this command to see the top 5 processes by their memory usage. So the command is simply saying the processes give us the detail, then sort by, so you say all the processes sort by equal sign percentage memory, MEM, then we pass it on to another command. We only want six of these processes, So it's given us 6 of them, 1, 2, 3, 4, 5. So it doesn't have up to 6. That's what that means. So it's giving us the services that are using the most memory by percentage. So this is it here. This is their percentage memory. You could also use this same command, but in this case, we remove the MEM and replace that with CPU to see the processes that are using CPU. So this is a CPU by percentage, right? So if you notice in this scenario, this particular service didn't show right here. This SB slash init is not showing up here for the memory, or it's using 0.1 CPU. So that's why it came up for the CPU. So it's not the exact same services that is brought up. Okay. So, and that is that. Now you create this file following the same convention that we've been using and document your findings, what you did, how the process went, what you learned, and once you're done, you save and the zip, you save the file, and then before you close out of this lab, try and practice with this without checking up on your notes. And that will be all for today. Thank you for joining and stay learning. Bye bye.